So welcome to this video number 5 in the phase equilibrium series. Here we'll study Clausius-Clapeyron equation. So we already come across Clapeyron equation, which is given by, change the color of the pen, dp by dt is equal to delta transition h, whatever the transition is, divided by t at which the transition takes place, delta transition of volume. So for a liquid vapor transition, liquid to vapor, transition, so this will reduce to delta P by delta T is equal to, so liquid to vapor is called vaporization, so it will be delta vaporization H divided by T, delta vaporization volume, right? Okay, now because what is delta vaporization volume is the volume of gas finally minus the volume of the liquid, right? But the molar volume of gas is so much greater than the molar volume of liquid. Then this is true, right? Gas occupies more volume than liquid. Therefore, what I can do is I can make this negligible, and entire delta V vaporization I can put it as in terms of V gas, that is molar gas. Okay, and moreover, if the gas behaves perfectly, your molar volume Vm of a gas is given by RT by Q. Now if I make that same substitution in this Clapeyron equation, okay, so it will reduce to dp by dt and this I can write it down, dp by p dt is equal to delta h divided by r t square. And now since dx by x is given by d ln x, now dp by t can be written as d ln p divided by dt, okay, delta v h divided by r t square. And this form is called as Clausius-Clapeyron equation. Okay. So this can be used to predict this equation can be used to predict how vapor pressure varies with temperature, or how the boiling temperature varies with pressure. So essentially, for example, if I have to take a real life example, now you would have seen your mom cook in a pressure cooker. Now, why is it better to cook in a pressure cooker than cook it open? So the reason is the added pressure will decrease the required temperature for it to boil, for the rice to boil. So it will happen quicker, right? So why does it happen quicker? Because due to the extra pressure, the temperature required to boil will reduce. That's the whole point. That's why it is often advised to boil rice in pressure cooker than in open. So if your enthalpy of evaporation is independent of temperature, so this thing delta H by R is a constant, delta H also, if it is independent, can come out when we integrate it. So if I integrate d ln P, where ln P star and ln P and since delta vaporization H is a constant as independent of temperature, I am going to take it out between integrate and into star dt by t square. Now if you do the integration, your ln P by T star should be equal to minus delta vaporization H by R, and in the brackets it's going to be 1 by T minus 1 by T star. Okay, so where this is very important, T star is the vapor pressure when temperature is T star, and P is the vapor pressure when temperature is T. Point to be noted, this delta vaporization should be there in terms of unit should be joules per mole. The reason is your R also is 8.314 joules per mole into Kelvin, and the temperature, both the temperatures should be in Kelvin scale because they have to cancel. So that's the whole thing. So this is your Clausius-Clapeyron equation. Now it can also be seen that if your pressure in terms of P star can be written as e to the power minus x, where x is given by delta vaporization H divided by R minus 1 by T star. So this was your Clausius-Clapeyron equation. And in terms of T, if you want to find your T, it is at a pressure P, it is given by 1 by T star minus, so you can just play around with the variables here, R ln T star by delta vaporization H 1 minus, right? So to the power 9. Similarly, you can also work out for what they can also ask you calculate what is the vapor enthalpy of vaporization, giving all other terms. So these are the different things that can be asked in question. Thank you.